So, I'm Mike. This is my interview for a video project for my microeconomics intermediate level class. Um, this is my first interview with my first student. This is my dad, Mike. Um, so to start off, we're going to start with some questions to gauge the student's information and education background. Um, so, where did you go to college?
The Philadelphia College of Pharmacy and Science.
What was your major at this college?
Pharmacy.
And while you were at this university, did you take any economics classes?
Yes, just the Intro to Economics basic course.
So you did not take any higher level economics classes other than that, right?
No.
Okay. So if I were to rank your familiarity with the topic of economics from 1 of never heard of it to 5 having addressed it in other courses or in other situations, what would you rank it?
4.
Okay. And then, so the topic of utility and budget is the first subject introduced in the class that I am the learning assistant for, intermediate microeconomics. Considering as the first topic, someone with relatively little knowledge of the concept should be able to figure it out easier than other topics. This concept becomes harder to understand when working with big numbers and also because of the need to understand how to do some calculus operations. For the sake of the student not understanding higher levels of math, I will use easy numbers to work with, and I will aid in the calculus operations. This topic explains the economic concept of spending money when faced with budget constraints in order to receive a level of satisfaction. In terms of allowing the student to understand what utility is, we can refer to utility as someone's level of satisfaction. So if I were to say that someone with a smaller amount of money or a smaller budget could have the same utility as somebody with a bigger budget or more money, would you say that's true or false?
I would say it's true.
So you think somebody with less money could have the same utility as someone with more money?
If they're sticking to a budget, I think so.
Okay. So in order to assess this, I'm going to use a common calculus economics problem that we did in class for the first week to help the other students who are actually in the class so far understand it. So my problem for understanding this concept of utility and budget will be a scenario such that Tim's parents give him $9 every day to buy Twinkies and Pepsi at school. The price of Twinkies is 90 cents and the price of Pepsi is 60 cents. Tim's preference for Twinkies and Pepsi is represented as a utility function given that it's x to the power 1/2, y to the power 1/2. So in this scenario, the amount of Twinkies are represented as x, the amount of Pepsi is represented as y. Do you understand everything so far?
Yes.
So what I want you to do now is I'd like you to draw just an x and y grid on the paper here. And then I'd like you to label that and make sure you're showing some of him on this. I'd like you to label that accordingly, saying that Twinkies would be on the x-axis.
Is this the x-axis?
That's not the x-axis. That's the y. That's the x. So Twinkies would be on the x.
Okay.
And
Pepsi.
Pepsi would be on the y.
Okay.
So then you could write down that you have $9 to spend. Tim has $9 to spend in this. And I told you that Pepsi was 60 cents and Twinkies were 90 cents.
Okay.
So the first step in finding Tim's budget would be to graph his budget line. In order to do this, you can first find the intercepts for Pepsi alone, assuming that he buys no Twinkies, and then Twinkies alone, assuming that he buys no Pepsi. So in order to find out if Tim bought all Pepsi, how much could he buy? What would you go about doing?
Well, I'd have to mark my graph to 15.
It doesn't have to be perfect, but
3, 4, 5, 6, 7, 8, 14, 15. So you can buy 15 Pepsis. Would be there. I try to use the same scale. 3, 4, 6, 7, 8, 9. We'll stop at 10. Because you can get 9 Twinkies, which would be here. So the line would be from here to here.
if you think that's what. So when you were doing Pepsi, could you explain how you found that it was 15? What did you do to come up with the number 15?
Divided 9 by 60 cents.
Okay, and then same thing for
Same thing
Twinkies.
for Twinkies, divided 9 by 90 cents. So it would be 10 Twinkies and 15 Pepsis.
Okay, so then you would say that this line represent Tim's what?
His budget.
Okay, so if he were to say pick a point up here, would he be able to afford that or not?
I would say not.
Because why?
It's on the wrong side of his budget.
And then for a different scenario, if there was to be a point in here, could he afford that?
Yes.
Okay,
He's below his budget.
right, okay. So if I told you his utility is represented as a function of utility of x and y is x to the 1/2, y to the 1/2. If you could just explain, if we were to find his utility at this point, what would you find his utility to be? So you can write down x to the 1/2, y to the 1/2 is his utility. So if you were to find it at this point, which numbers would you plug in for x and y?
Up here,
So yeah, if you're doing,
x would be 0, y would be 15.
right, so then for the sake of calculations, you can plug in 1/2 would be the same thing as the square root of a function. So what number would you plug in to take the square root of in order to find it?
15.
Okay, so you can do that. You gotta do
Oh, I don't know.
the square root first,
Yeah. Haven't used that for a while.
and then click enter.
Where's enter? Oh.
Um,
So 3.8729.
So we could just say that his utility at this point would be 3.9, right?
Okay.
So you can label that
3.9.
3.9. And then how about at this point, if you were to find his utility at this point, what would you do? Which numbers would you plug in?
Well, I guess x would be 9 and y would be 0.
Yeah,
So it would be square root of 9, which is 3,
right,
correct?
Yeah.
So here it's just 3.0.
okay. So if you're comparing this point to this point, and what I told you about utility is that it's a satisfaction level,
Right.
which one do you think Tim would prefer?
I guess the 3.9,
And why
because it's
would you-
higher.
Because it's higher than 3.0?
Right.
Okay. So if you could write a budget function in the form of, you can write down this.
Mhm.
I is equal to x times the price of x.
How do I do price of x?
You can just say that's px
Okay.
plus y, price of y. So this is your sample budget constraint.
Okay.
I is your total budget X would be the amount of you have of X, in this case is Twinkies. PX would be
Price.
your price of Twinkies plus Y times the price of Pepsi.
Okay.
So in order to, how would you write it if you were to be at this point?
At that point, it would be, X would be 0 times P times 0.9 plus Y would be 15.
So it's just your price. You don't have to write P. So
Oh.
at this point, it's just 0.9.
And then 15 times 0.6.
Yeah. So what do you get at that? What is your I?
I would equal 9.
Okay. And if you were to say that instead of getting 0, what would change in relation to 15? So let's say he doesn't want 15 Pepsis. He wants at least 1 Twinkie. How do you think this would change? Do you think this number would go up or down?
If 15 would go down.
Right, so he's giving up a Pepsi in order to obtain the Twinkies.
Right.
Okay.
Yes.
So for needs of simplifying this in order to avoid going into higher levels of calculus, let's assume that Tim's optimal choice, his best choice, would be somewhere in here.
Right.
It can just be arbitrarily marked for now. I want
Okay.
you to just label that, and you can label it point A.
Okay.
So at this point, he's getting however many Pepsi and however many Twinkies, and let's just say that he likes that better than all the other combinations that he could get along this line.
Okay.
So if I told you a utility line or an indifference curve is downward sloping, and this represents his best choice here, how could you demonstrate his utility on this curve?
Well, this is, and it's a downward slope.
Yeah.
If this is his optimal,
So that's his best.
would it be on this side of the graph like that?
Yeah. So why did you draw it like that?
I'm not really sure, because you said it's a downward slope. This is where it intersects most with his budget. And here, I don't know, is it on the wrong side of his budget?
No, it's right.
Okay. Is this a measure of his satisfaction?
So that's the same thing that we found earlier.
Okay.
His budget, if there were to be a line coming through here, it would be 3.9. The value would be 3.9 versus here would be 3.0.
Right.
So we're just going to assume for now that A is greater than everything else that he can get without going into the numbers. So we're
Okay.
just going to make it simpler that way.
Okay.
So let's assume that first we could assume Tim's budget. So instead of him getting $9 from his parents every day, let's assume that his parents are going to give him less money one day.
Okay.
So how would, you can draw it on the same thing, how would his budget line change
It would be down here.
if he gets less money?
If he gets
Yeah,
less money.
we're not going to say specifically, but
Right. It would be on the left side of the budget line.
so he would have less money to spend on Twinkies and Pepsi,
Right.
both. Okay.
Right.
And then if he would have more money, how could you draw it? You could like do a dashed line or something.
It would be on the upper or right side of the current budget.
And your reasoning for that would be with more money.
He can buy more product.
Okay. So now let's assume that we're going back to him getting $9 from his parents every day.
Okay.
And we're gonna keep the price of Pepsi at 90 cents,
Mm-hmm.
but we are going to make the price, the price of Pepsi is 60 cents. So we're gonna change the price of Twinkies, and we're gonna make Twinkies, let's just say, 1.8, so $1.80.
Okay.
So can you draw, and you can erase these if it makes it too complicating to think about all that, but if you were to draw his new budget line, given that he still has $9,
Mm-hmm.
Pepsi stays the same, and Twinkies increase, how could you show me how you would draw his new budget line?
Well, this would stay the same.
Yeah,
So now he would, can I use a calculator?
yeah.
Where's your clear function? Is it already cleared? Oh, there it is.
So you can start.
So 9 divided by 1.8. Yeah, 5.
Yeah, the calculator says 5.
Okay.
So could you just write down what calculation you did on the computer on the paper here, just so I know for later?
I divided
$9.
$9 divided by 1.8 equals 5.
Okay, and then can you show me on the graph how you would represent this new budget line for
2,
Tim?
3, and 4. So 5 would now be here. So it would go. Trying to make a straight line.
As best as you can, but it's
There.
okay. Okay. So we would say this is, at this point, how could you find his new utility? So remember, this is his utility function.
Right.
So now
For
he's
the
getting
utility for Twinkies. X. I kind of forget how we did it the first time. X
So I
and Y.
told you that's your utility function, and
So if we got 0 Pepsis,
he's getting 0 Pepsi in
he's
this.
got X to the half.
Yeah. So how many X does he have in this first scenario? In the beginning, how many did he have? You said he had
15.
9. This one's 15.
Oh, okay.
So you said he had 9 here.
Okay. Oh yeah, he had 9 Twinkies, correct.
Right.
Now
So
he
then
has
you
5
said
Twinkies.
his utility was 3, right?
Where's the square root?
So it was the square root 9, the square root of 9.
Right, and so
So-
we got 3. So now I need the square root of
Your new
5.
right.
So clear that. Square root of 5. 2.236.
So you can just say that's
2.2.
2.2.
Okay.
So which one of these points here do you think he prefers?
I'm sure he would prefer this point to 3.
For the reason that
He gets more Twinkies.
right, and his utility is
Higher.
okay. So then, same thing. We're going to pick a random point that would be about right if we were to do the actual calculations, but to avoid doing complicated numbers, we could say his optimal point would be there.
Okay.
So if you were to draw his utility at this point, what would it look like?
More like this.
Right. So, without knowing the numbers for this, but seeing that this point is higher values of x and y compared to this point, what would you conclude? You could say this is point B. What would you say is his preferred point?
A.
So he's better off when he has more or less money
More.
because he can buy more, correct?
Right.
Okay. So we said that his utility at A is going to be higher than his utility at B, but we don't know the values of his utilities because we're kind of using arbitrary numbers for his x and y.
Mm-hmm.
So let's say, to just make up one, that one utility is going to be higher than the other. Which one would you guess to be higher than the other? So if we put labels onto these utility curves,
Mm-hmm.
let's just say one would be a utility of value 1, one would be 2.
I would say this one would be 1. This one would be 2.
So why would you say that?
Because it's higher. It has a higher value.
So you're saying it has a higher value, but you labeled it 1. 1 is lower than 2. Or did you label it 1 as in 1 ranked
Yeah.
higher than 2? Okay,
Number
so
one.
you just said that. Okay.
Yeah.
So then, and visually, just from looking at the curves, what tells you that A is higher than B?
Because it's on a higher level on the graph.
Okay. So then, the next step in order to evaluate a person with 2 different budgets, what we would do is we would basically just take Tim's budget after his money from his parents gets decreased, and we're going to try and slide it over to this curve so that his budget intersects here. So in order to do that, we just want to try and keep it parallel to this curve so it's the same. So now this pretty much tells us that Tim has the same amount of money here as he does in here, but now he's back onto his original indifference curve, which we said was better than the other one.
Okay.
So now you have a new intersection, and it's a little bit poorly drawn, but or would you label his new point? So we're gonna have a point C here.
Somewhere right here.
Yeah, it's gonna be like that. So now you're saying compared B to C, which do you think Tim would be more would have more utility at?
C.
Okay, and then let's say compared A to C, do you think what do you think his preference would be?
C.
Okay, why would you say that?
Because it looks like it's higher on the graph.
It's higher on the graph. Okay, so
Is that a better point?
okay. So we said his utility here was better than his utility here, though,
Mhm.
right?
Yes.
What if I said that his utility, if I were to put another point, let's just say here, compared to B and this point, do you think he's changing at all? We said this is his level of satisfaction.
Right. I guess no, because it's not intersecting with his budget.
So no, what? He
He's not
takes the
as,
same, or
B would be better than a new point. Or B would still be better. No?
well, if I told you that no matter where you are on here,
Yes.
you always have the same value of utility,
Okay.
does that change your mind at all? For just sticking on to one curve.
Then I guess there would be no difference between those two.
Okay, so then if you were to take that in the same thing,
Then I guess there would be no difference
So
between
you'd
C
say-
and A.
so in other words, you'd say his preference is at C is equal to his preference at A.
Yes.
Okay, and then so what about his preference from C or A compared to B? One more time.
C or A would be better than B.
Okay, so basically what we just said is that he has the same budget line here because it's parallel, we just shifted it over,
Mm-hmm.
but his utility here is better than at B.
Yes.
So in essence, in the beginning, we said people with different budgets would have different levels of satisfaction or utility. But what we kind of just did here is we kind of disproved it, ignoring some of the mathematical computations of it and simplifying it to make it easier to understand without doing all of the mathematical operations. So if I were to ask you again, if someone with a smaller budget could have the same utility as someone with a bigger budget, do you think that would be true or false?
If they had a smaller budget rather than a bigger budget, would they have the same utility? No, that would be false.
Okay.
They wouldn't have the same satisfaction.
Okay. And then lastly, what I always want to do here is we're going to go a couple of different situations with budgets and utility. So we're going to ignore all of the numbers pretty much, but it's going to be the same concepts. Okay. So let's write let's just go over this, I guess. So we have his budget line is this line.
Mm-hmm.
And we said his optimal point we're going to pick here is point A, where his indifference and his budget line kind of meet. So if we went to C, as far as budget goes, could he afford this?
Yes.
Okay. And then as far as B, as far as his budget goes, could he afford this?
No.
Could you tell me why and what tells you that he could afford this but not this?
Because if this is his budget line, anything on this side below it would cost him less. Anything above it represents a higher number than his budget.
Okay. So then you say A and C are affordable.
Yes.
And then B is not affordable.
Right.
In terms of utility, which of these would give him the highest utility, C, A, or B, if you rank them?
Its highest utility,
Yeah,
whether he can afford it or not,
right.
would be B.
So B, then what would be next?
A. And then C.
Let's see. And without assigning these numbers, what tells you that from just looking at this graphically?
Just because their values are much higher.
Because,
B's value is higher than A's value. A's higher than C's
okay.
because of where they're at on the graph.
Okay, so then if, let's pick another point and excluding his budget. So we're saying his utility at D is on the same curve as the utility at A.
Right.
Ignoring his budget, do you think Tim would prefer D to A or A to D, or do you think he has no preference because they're on the same curve?
I think he has no preference because they're on the same curve.
Okay, so we said D is equal to A,
Right.
the utility at least. But then in terms of both his utility and his budget, at what point is Tim going to buy his quantities of Y and X? So out of all of these, given his budget and his utility, which point does he choose?
A.
Okay. And why would you say that?
Because that's where it intersects with his budget.
Where what intersects?
Well, A intersects with his budget at that point.
So
His
you,
utility intersects with his budget there.
okay. So from saying that, can Tim afford A or not?
Yes.
And then his utility at A is the best because in terms of things that he can afford, it would be better than C.
Yes.
Okay.
Okay, so explain to me why A is equal to D on this utility curve.
Okay, so when you're on a utility curve, that means that anywhere on the curve, your utility is going to be a set value. So in order to answer this, I think it would be best if I assigned random numbers that are going to follow what we already said. So we said B is greatest, A would come next, and C is the least.
Right.
So in order to show that through numbers, we can say the utility is C is equal to 3. Utility at this point, we'll say A or D is equal to 5. And we can say the utility of B is equal to 7. So no matter where you are on his utility curve, even if it's up here or down here, his utility stays the same as long as you're on the curve.
Mm-hmm.
So if I say that and I say, what's his utility at D?
It's 5.
And then what was his utility at AB?
5.
And then if we just randomly started with another one here,
That would also be 7
okay.
with B.
So B and E would be his greatest, their value is at 7. D and A would be the next, their value is at 5. And then C would be least because his value is at C. However, in the end, when we have to consider Tim's budget and the price restrictions as well as the prices of Pepsi and Twinkies, what would his ending point be, and what would the value of his utility be at the point that he chooses?
It would be A, which is 5.
So we said A, which is 5. So Tim's best choice would be at point A.
Right.